4.4.6. The smaller circle must be translated by k units along the x-axis to touch the larger circle internally. Calculate the possible values of k. Okay, so we have two possible values of k. Question 4.6 is not for the faint-hearted ones. I hope I don't turn out to be faint-hearted. So let's just go ahead and give this question a try. Okay, let's start with 4.1 and hear the stories. So given that D with coordinates P and minus 2 lies on the smaller circle, show that P is equals to 4. Okay, we're given the equation of the smaller circle. We have x squared plus y squared is equals to 20. So the value of x at point D is P. So if we substitute that, we're going to have P squared plus the value of y squared, which is minus 2. So minus 2 squared is equals to 20. P squared plus 4 is equals to 20. P squared is equals to 16. So P is equals to 4. Okay, P can be equals to 4 or minus 4. But as we can see, the x value of D should be positive. So that's why we're saying that P is equals to plus 4 and not minus 4. No trickery there whatsoever, just basic stuff. Let's take a look at 4.2. So 4.2, we are told that E with coordinates, let's take a look, coordinates 6 and 2. Okay, is the midpoint of DF. Determine the coordinates of F. So we have the coordinates of D, 4 and minus 2. The coordinates of E, and we are looking for the coordinates of F. E is the midpoint of DF. So x of E is equals to x of D plus x of F, everything divided by 2. X of E, that is 6. X of D is 4 plus x of F, everything divided by 2. If we cross multiply here, we get 4 plus x being equals to 12. So x is equals to 8. The x coordinate of F is 8, which makes sense. Even if we just use translation, it should be easy to see that the x coordinate of F should be F. Okay, and then the y coordinate of F should be equals to 6. Let me show you why. So the y coordinate of F is equals to, not of F, but of E. We are using E as a bait to find that of F, right? So the y coordinate of E is equals to the y coordinate of F plus the y coordinate of D, everything divided by 2. That of E is 2, that of F we're interested in, and that of D is minus 2, everything divided by 2. 2 multiplied by 2 is 4, so we have y of F minus 2 being equals to 4. Y of F is indeed equals to 6. So the coordinates of F, we have 8 and 6. Okay, we're not experiencing any difficulty up to so far. We are moving at the speed of light. Okay, let's do 4.3. So 4.3, determine the equation of the common tangent df in the form y is equals to mx plus c. So y is equals to mx plus c. We want the equation of df. It's a straight line. We just need the gradient, substitute 1 point, and we are done. So let's find the gradient of fe. As all the coordinates are positive, they're easier to navigate. So y2 minus y1 divided by x2 minus x1, okay? So y2, the y coordinate of f, that is 6, minus the y coordinate of e, which is 2, divided by the x coordinate of f, 8, minus that of e, 6. 6 minus 2, that is 4. 8 minus 6 is 2. 4 divided by 2 is 2. So we have y being equals to 2x plus c. Let's substitute our point E. So if we sub E of coordinates 6 and 2, we're trying to find the value of c, okay? The coordinate of E it gives us a x value and its corresponding y value. So we're going to have 2 being equals to 2 multiplied by 6 plus c. It is easy to see that c is equals to 2 minus 12, which is equals to minus 10. So we have y is equals to 2x minus 10. Okay, it makes sense because when x is 0, y is equals to minus 10. And if you look at this line, that makes sense that the y-intercept x is equals to 0 can be minus 10. Okay, that is 4.3. Let's do 4.1. Let's hear the stories. 4. Not 4.1, but 4.4. What am I saying? So in 4.4, we want to calculate the value of t and show all working. Okay, the value of t. Right, I see the idea we're supposed to use here. So df is the tangent to the smaller and the larger circle. That tells us that m of tangent multiplied by m of the radius. Gf is the radius, as you can see. M of gf should be equals to minus 1. Okay, the gradient of the tangent is 2, like we calculated above. So we have 2 multiplied by the gradient of gf, which is equals to minus 1. So the gradient of gf is equals to minus a half. Okay, how can we use that to find the coordinates of t? If we use gf to find that gradient of minus a half, the only unknown variable will be t. Let me show you what I'm talking about. So we can say that the gradient of gf is equals to y2 minus y1 divided by x2 minus x1. So we have minus 1 divided by 2 being equals to y2. Let's take f as our second point and g as our first point. If we do that, we're gonna have y2. So f as our second point, that's gonna be 6 minus y1, which is y of g, 0, divided by x2, 8 minus t. Okay, let's go ahead and cross multiply. I'm taking minus 1 divided by 2 as one number. So that is how I'm cross multiplying. When I do that, I'm going to have 6 being equals to minus 4 plus a half t. If I take minus 4 to the other side, a half t is equals to 10. So t is equals to 20. Okay, so there we go. We have the value of t. That is 4.4. 4.5, 4.5. We are moving at the speed of light. We're really close to doing 4.6. Let's do 4.5 first. Determine the equation of the larger circle in the form ax squared plus by squared plus cx plus dy plus e is equals to 0. Okay, let's take a look at the information we have. We have g, which is the center, right? Coordinates t and 0. We know that t is 20, and then we have the y coordinate, which is 0. What else do we have? We need the center and the radius at least to talk about the equation of a circle. So let's go ahead and see how we can conjure up the radius. So the radius, well, the radius squared, okay? Let's find the radius first, and then we're going to find the radius squared, okay? So this is going to be the square root of the distance formula. GF is the radius. So if we find the length of GF, then we have the radius, okay? So this is y2 minus y1 squared plus x2 minus x1 squared. So the radius is going to be equals to, I'm taking f as the second point. So y is 6 minus 0 squared plus 8 minus 20 squared. Okay, so 6 squared 36, and then minus 4 squared 144, 144 plus 36 180, 180. So I have square root of 180. Can I further simplify that? Let me put it in my calculator. Okay, if I further simplify it, I get 6 square root of 5 as r. So that's my value of r. If we go ahead and find r squared is going to be 180 if r is equal to square root of 180. Okay, so right now we can have x minus the value of t, 20 squared, plus y minus the y coordinate of t, not the y coordinate of t, but the y coordinate of g, which is 0. So we have 0 squared being equals to radius squared, which is 180. Okay, so now what we need to do here is just to solve all this and take 180 to the left-hand side. And then we're going to have the equation of our circle in the form we are required to have it in. That is going to be x squared, x multiplied by minus 20, that is minus 20. You multiply that by 2, you get minus 40x. Minus 20 multiplied by minus 20, that is plus 400. And then y squared, that is plus y squared. You take 180 to the other side, we have minus 180 being equals to 0. So x squared minus 40x. Let me look at the form so that I don't ruin it. Okay, after x squared, I shall follow with by squared. So x squared plus, what am I doing? Okay, let me look for that again. Where am I? Okay, yeah, so x squared plus y squared minus 40x, and then I need plus dy. Okay, which term has a coefficient of y? There's no term with a coefficient of y, so just to act cheeky, I'm gonna say plus 0y. Okay, and then 400 minus 180 is that plus 220. I think this is plus 220 is equals to 0. I'm supposed to write the equation of the circle in that form. Okay, that is 4.5. The interesting question, really, 4.6. Yeah, this is interesting. Not for the faint-hearted ones. I hope I don't fall under the domain of those with the faint of heart. The smaller circle must be translated k units along the x-axis to touch the larger circle internally. Calculate the possible values of a. So let's make sense of what we mean when we say the touch internally. Okay, so let me do something. Let me trace this circle. Let me use the color red. You're gonna see why I'm doing that. Just stay with me. So I'm gonna trace this circle to the best of my ability. Okay, what I want to do now is to duplicate it. You will see why I'm doing that. Duplicate, and then now let's leave it there. So not there, but yeah. Okay, so when this circle is positioned like that, then the larger circle and the smaller circle are touching internally. That's what we mean. But that is not the only possible scenario. Let me show you the other possible scenario. So I have to duplicate it. When they touch like that, that is another possible scenario where our condition is satisfied. They are touching internally. So this is option 1 and this is option 2. If they're touching like that, we can say that they are touching internally. That's what we mean when we say they touch internally. Okay, so there's two ways of doing this. You can do it in an algebra intensive way, or you can just analyze the diagram like I'm about to do right now. Okay, so let me just enlarge this and show you something. Right, so I will erase all this so that I have somewhere to write, and I'll show you what I'm talking about. Okay, I don't want to erase the larger circle. What am I doing? The larger circle must be there. All I want to erase is all these words so that I can have space to write in. Right, so the center of the larger circle, we have 20 and 0. Okay, and then the center of the smaller circle, we have 0 and 0. But we have the radius of the smaller circle. The equation for the smaller circle is given by x squared plus y squared is equals to 20. So the radius is square root of 20. Okay, let's look at this point. Let's concentrate on this point. The x coordinate of that point is minus square root of 20. Okay, if the radius of the circle is square root of 20, we need to comprehend that, right? So that is step number one. We need to be able to realize that. Another thing that we need to realize is, or that we need to figure out, is the coordinate, is the x coordinate of this point that we are interested in. How can we find the x coordinate of that point? Let me show you. We know that from this point to the center is 6 square root of 5, or let's just say square root of 180. We know that for sure. But from the center of the Cartesian plane to the center of the circle is 20 units. So if we want to find the x coordinate at this point that we're interested in, we can just say that, let me enlarge where I have to write now. We can just say that the x coordinate at that point, let's call it q, right? The value of q is equals to 20 minus square root of 180. We want to move this x coordinate at that point such that it is equals to 20 minus square root of 180, right? We can have an equation for that which we call q prime. So q prime is equals to minus square root of 20 plus k, right? So when q prime is equals to q, then we can determine the value of k such that the circles touch at this point. Okay, so that is 20 minus square root of 180 is equals to minus square root of 20 plus k. Okay, so k is equals to 20 minus square root of 180 plus square root of 20. Right, so let me just go ahead and put that in my calculator. Let me see what I have. I'm getting k is equals to 20 minus 4 square root of 5, which in decimals is 11.05. So this is one possible value of k. Yeah, this is the same thing. Yeah, one possible value of k. Now let's look at the other case where they touch in at this point. Okay, so let's find the x value at this point. Let's call it z. So z will be equals to the x value at the center, the x value at t, which is 20 plus the radius of the larger circle. So 20 plus square root of 180. Okay, so we want these two circles to touch at the point 20 plus square root of 180. But z prime now will be equals to square root of 20 plus k and not minus square root of 20 plus k. Okay, so if we equate these two, we get square root of 20 plus k is equals to 20 plus square root of 180. So k is equals to 20 plus square root of 180 minus square root of 20. So k is equals to 20 plus square root of 180 minus square root of 20. This is equals to 20 plus 4 square root of 5, of which is 28.94. So these are two possible values of k according to me. Let me know what you think in the comments. I'm quite sure there must be somebody who used the same method I'm using. Just let me know in the comments. Which video do you want me to do next? We have done question 1, 2, 3, 4. Should we just do 5, 6 until 10, or should we? Let me know in the comments.